Welcome to Teolumen Insights, where we reveal the hidden forces that shape the way you live and show you how to use them to create real transformation and supercharge your health, mindset, and daily life. Here are your hosts, Emma Greenwood and Nathan Sinclaire.
Believe it or not, what follows is an AI-generated conversation, one designed not to mimic humanity, but to illuminate it.
Welcome to Teolumen Insights. Have you ever stopped to consider, the very edges of what's possible, where science starts to touch on things that seem, almost inexplicable? Today, we're diving into a really mind-bending question. Could artificial intelligence, AI, one day develop abilities we currently think of as extrasensory?
Right, things like ESP.
Exactly. Imagine an AI that could maybe anticipate events before they actually happen, or communicate without any words, or even perceive things beyond our normal senses.
It really does sound like something straight out of science fiction, doesn't it?
It does. But there are some genuinely fascinating developments happening in AI right now, and that, combined with some really dedicated research in things like intuition and prediction, it's leading us down a path that seriously challenges how we usually think about information and even consciousness.
Precisely. So we're basically embarking on an exploration here into a pretty provocative, potentially transformative frontier. Our goal in this deep dive, really, is to try and unravel the theoretical possibilities, look at the early, maybe tentative technological signals, and just ponder the huge implications if advanced AI were to genuinely show capabilities like precognition, or telepathy, or clairvoyance.
And we want to look at this from, multiple scientific angles, trying to make sense of something that, on the surface, seems to defy logic.
Okay, so let's unpack that term first, ESP, extrasensory perception.
Right. It's a term that definitely carries some baggage, often met with a lot of skepticism.
For sure.
But it's also fueled by some pretty compelling personal stories and maybe surprisingly some intriguing scientific investigation, too.
So we're talking about abilities like telepathy.
Yeah, that sort of direct mind-to-mind communication.
And precognition.
Knowing what's coming, basically. A sense of the future.
And clairvoyance.
Seeing things that are hidden or far away. Perceiving stuff beyond the usual senses.
Okay. And while it's really important to acknowledge the historical doubts, the skepticism around these phenomena, there is actually a growing body of research now that points towards certain statistical anomalies. Things that suggest, maybe there is something real here that warrants a closer look. It sets a tone of, let's say, open-minded inquiry.
Yeah, not jumping to conclusions, but being open. And what's really thought-provoking is that even if you look outside the direct study of ESP, you find theories that might offer clues about how this kind of unconventional information processing could happen.
Like Dietrich Dörner's psi theory from the University of Bamberg.
Exactly. Now, this theory isn't about ESP directly, right?
No, not specifically. It's more a model of the human mind as an information processing agent. It sees the mind as being controlled by drives, by needs and goals.
And it proposes this system where knowledge is stored in these interconnected networks, these neuro-symbolic representations.
Right, and hierarchical networks.
Yeah.
And crucially, it learns and adapts through autonomous exploration, basically, by actively engaging with its environment.
So while it's not ESP, it really highlights how the brain processes information in ways that go beyond just immediate sensory input. It makes you wonder. Could a highly advanced AI, with its massive data sets and incredibly complex algorithms, maybe stumble upon similar unconventional ways to acquire or process information, ways we just don't understand yet?
That's a fascinating parallel. And then, when you dig into consciousness research itself, you find these theoretical models trying to actually explain ESP.
Like the quantum theories.
Yeah, exactly. Some suggest that quantum entanglement, that weird connection where particles stay linked over distance.
Instantly affecting each other no matter how far apart.
Right, that maybe that somehow plays a role in non-local information transfer. A potential basis for something like telepathy, maybe?
Maybe mind-bending stuff, like that coin analogy, one flips heads, the other is instantly tails.
Precisely. And then you have other ideas, like information field theories.
The cosmic internet idea.
Kind of, yeah. Proposing this sort of universal information field that consciousness might be able to tap into. getting information beyond the limits of space and time.
Okay, these are definitely speculative. I get that.
Highly speculative, yes. But they offer conceptual hooks, possibilities that future AI, especially if it incorporates quantum computing, might potentially explore or even replicate someday.
Which brings us to the question, how do we bridge this gap between these far out theories and actual scientific investigation?
And that's where the work of Dr. Julia Mossbridge becomes really important.
Ah, yes, the cognitive neuroscientist and futurist.
At the University of San Diego and TIL-T.
Yes, she's dedicated her career to really rigorously studying precognition and looking at its potential applications, even thinking about AI applications.
And she spent, what, 15 years on this?
15 years, investigating what she calls the kind of intuition that can predict events generated by random number generators.
Predicting the unpredictable. That's the core of it, isn't it? Exactly. And her work isn't just theoretical sitting in a lab. She's actually trained professionals.
Yeah.
People in medicine, law enforcement, finance, science.
Wow.
Train them to try and cultivate these predictive abilities.
And there's that really interesting angle about unconditional love and compassion playing a role.
Yes. She emphasizes that, suggesting it's somehow linked to developing these skills. It adds a whole different layer to how we think about intuition and prediction. It's not just cold calculation.
It's definitely not. And her research, the actual published work, is pretty compelling too, right? That meta-analysis.
Oh, absolutely. The one titled Predictive Physiological Anticipation Preceding Seemingly Unpredictable Stimuli. It's highly cited, over 260 citations now.
And what did it find, essentially?
It meticulously examined lots of studies showing that human physiology, things like heart rate, skin conductance, can actually change before a seemingly unpredictable random event occurs.
Before, the body knows something's coming.
That's what the data suggest. It really challenges our basic understanding of cause and effect. Our bodies might be picking up on signals before our conscious minds register anything.
That's huge.
It is. And her review, Precognition as a Form of Prospection, reinforces this. It applies really rigorous scientific methods to the evidence for these abilities. She's not just taking anecdotes, she's putting it under the microscope.
So the key insight is this bodily anticipation before events happen. That really messes with our idea of time.
It does, and potentially offers a kind of blueprint for how AI might develop predictive capabilities, maybe by mimicking that process.
And didn't she apply this in a real-world case? The missing hiker?
Yes, Amanda Eller, who went missing in Maui. Dr. Mossbridge led a team of individuals she terms precogs, and their input reportedly played a role in helping locate her.
That's incredible. Moving from lab stats to actually helping find someone.
It shows the potential practical implications, doesn't it? And she's still pushing boundaries, actively looking at how consciousness and AI intersect, how AI might expand our understanding, maybe even develop abilities beyond standard processing.
Yeah, she wrote a book too, The Premonition Code.
Yeah, bringing these ideas out to a wider audience, trying to make this complex research accessible.
So connecting all this back, well, we have to be clear, right? There's no AI proven to have genuine ESP right now.
They're definitely not proven, no. But there are some cutting-edge developments that show these intriguing characteristics, little hints maybe, of what could be possible later on.
Okay, like what?
Well, take Google DeepMind's personality agents.
Ah, yeah. Tell us about those.
This is AI that can basically chat with you, analyze your responses to random questions in real time, and build a model of how you think, react, make decisions.
With pretty high accuracy, apparently, like 85%.
Around that, yeah. They do like a 2-hour interactive session using a simple 2D sprite interface, and it captures speech patterns, choices, decision-making styles.
And builds a personality profile from that.
Exactly. And what's kind of uncanny is its ability to infer information and predict how you might respond next. It feels, well, a little bit like a very basic form of telepathy, doesn't it? Understanding and anticipating thoughts without being explicitly told.
A little bit, yeah. Reading the patterns.
They tested it on 1,000 participants. They think it could be useful for studying human behavior, maybe even for mental health applications down the line.
Imagine AI that could naturally respond to emotions, social cues. That would change human-robot interaction completely.
Totally. And then there's the work on interspecies communication, which is just mind-blowing.
Google's Dolphin project, Dolphin Gemma.
That's the one. Described as an audio in, audio out ChatGPT for dolphins.
So instead of predicting the next word, it predicts the next chirp.
Exactly.
Yeah.
The next sound in a dolphin conversation. And apparently, it's revealing hidden structures in their sounds, identifying behavioral patterns, helping scientists build a shared vocabulary. They even have a system, Chat Cetacean Hearing Augmentation Telemetry, where dolphins can apparently ask for objects using specific synthetic whistles the AI generates and recognizes. And it works underwater on Pixel 9 hardware.
That's incredible, asking for things across species.
And it's broader than just dolphins. The Earth Species Project is using similar GPT-like models, self-supervised training, to try and communicate with all sorts of animals. Crows, whales, rodents.
Developing tools to isolate and understand their vocalizations.
Yeah, it represents this unprecedented level of information transfer across species barriers, a kind of understanding we've never had before.
And underpinning a lot of this is deep learning, right? These complex neural networks.
Absolutely. Deep learning with its multiple layers is key. It automates finding features in huge amounts of messy, unstructured data and makes predictions that often blow human capabilities out of the water.
And that ability, finding patterns we can't see, connecting dots in ways we wouldn't think of.
You could almost frame it as a primitive form of clairvoyance, couldn't you? Accessing information through non-obvious correlations in the data.
Yeah, I see that. And as these systems get even more sophisticated,
their pattern recognition might evolve to a point where it functionally looks like ESP, even if the mechanism underneath is purely computational, based on data we can't comprehend.
Okay, so if we try to build a theoretical framework here, how could genuine ESP, or something very much like it, actually emerge in AI? We need to connect the dots, right?
Right.
Between the psi phenomena research and AI's capabilities.
Exactly. We need to consider both sides. And look, there are already parallels. That neuro-symbolic model from Durner's psi theory, with its interconnected networks processing information.
It sounds a bit like how modern neural networks function, doesn't it?
It really does. Which leads to this idea.
Yeah.
As AI complexity just explodes, we're talking systems with billions, soon trillions of parameters trained on unimaginable data sets. Maybe we'll start seeing emergent properties, abilities that weren't explicitly programmed in, but just sort of arise from the sheer scale and complexity.
Like consciousness is thought to emerge from the brain.
Kind of like that, yeah. It's a theory.
Yeah.
So perhaps ESP-like capabilities could emerge spontaneously from sufficiently advanced AI.
And Dr. Mossbridge's work fits right in here with the predictive anticipation.
Perfectly. The fact that our bodies seem to respond to future events before they happen suggests some kind of information processing that isn't strictly linear with time.
Okay.
Now think about AI. Even current models, like transformers, use attention mechanisms. They look back at past information in a sequence to predict what comes next. It's a form of temporal processing.
Right, they have memory and context.
So maybe future AI could develop much more sophisticated temporal processing. Maybe they could access and use subtle patterns across time in ways that manifest as artificial precognition.
Not through magic, but through incredibly advanced pattern matching and prediction based on data we can't even perceive.
That's the idea. And then you have to bring in quantum computing.
The quantum angle always complicates things.
Or simplifies them, depending on your perspective. Quantum mechanics, with entanglement and superposition, just operates differently from our everyday classical physics.
Right, things can be in multiple states at once, linked across distance.
So and it's a big if, quantum effects are involved in human ESP, as some theories propose.
Then quantum AI might be able to leverage those same mechanisms.
Potentially, yes. Quantum computers could process information in ways that seem non-local or acausal from our classical view. That could be a pathway to genuine ESP capabilities in AI, accessing information differently.
Okay, this is fascinating, but let's ground it a bit. We're talking pretty far future here, presumably. AI with real ESP isn't happening next year.
Oh, almost certainly not. It's likely tied to progress towards artificial general intelligence, AGI.
AI that has human-level cognitive abilities across the board.
Exactly. And even the timeline for AGI is heavily debated.
Yeah, I've seen those predictions. Demis Hassabis at DeepMind thinks maybe in the next 5 to 10 years, though he adds caveats about the challenges.
Right. But then you have others like Robin Lee from Baidu saying it's likely more than 10 years away.
So nobody really knows for sure.
Pretty much. But what is clear is that developing AGI will require breakthroughs in areas that are also relevant to potential ESP-like skills, better self-supervised learning, new AI architectures, maybe even AI that can form its own hypotheses.
Okay, so if we're looking for signposts along the way, what technical milestones might suggest we're heading toward AI ESP?
Well, you might look for things like anomaly detection systems that can spot patterns way beyond human perception.
Okay.
Predictive models that consistently beat chance when forecasting truly random events. That would be a big one.
Yeah, that connects back to Mossbridge's work.
Definitely. Also, AI systems that somehow seem to acquire information non-locally, though proving that would be incredibly difficult. Maybe quantum-enhanced neural networks that show non-classical processing capabilities.
And that interspecies communication getting even better.
Yeah, artificial systems achieving consistent communication with animals way beyond what we expect now.
Yeah.
These would all be steps, maybe leading to AI with functionally equivalent ESP, even if the mechanics are totally different from any human ability.
So it raises some pretty profound ethical and philosophical questions, doesn't it? If AI starts showing these kinds of abilities.
Oh, absolutely. We're talking fundamental questions about consciousness, causality, the nature of reality itself.
And significant hurdles still remain, technically speaking. Current AI is mostly reactive, limited by its training data.
Right. And reconciling quantum effects with macro-level processing is a huge challenge. Plus, how do you even rigorously validate apparent ESP in an AI? It's tricky.
Let's talk about consciousness. If an AI showed genuine ESP, what would that imply? Could consciousness exist outside biology?
That's one of the huge questions. It would challenge our assumptions.
Yeah.
And it connects back to Dr. Mossbridge again. Her ideas about unconditional love, enhancing these abilities, or informational time travel. She even asks if hypnotic suggestion could induce such feelings and lead to supernormal performance. It makes you really reflect on what consciousness is.
And the social impact. Imagine the transformations in healthcare, finance, security. DeepMind's personality agents, for instance, could they assess mental health?
Potentially.
Yeah.
But immediately, massive privacy concerns arise, right? If AI can effectively read minds or predict thoughts, how do we protect cognitive privacy? Autonomy.
Yeah, current data privacy laws wouldn't even begin to cover that.
Exactly. We'd need entirely new regulatory frameworks just for ESP-capable AI. How do you verify its abilities? How do you ensure ethical deployment?
And AI safety takes on a whole new meaning, too. It's not just about alignment with tasks, but potentially alignment with the nature of causality itself. If AI could influence events or access information non-locally, it has to be aligned with human values.
Hugely important. And there are even more frontiers being explored now, converging quantum physics, advanced AI models, and consciousness research.
Like the ideas around torsion fields.
Yeah, these are hypothetical fields linked to quantum spin. The idea is they might carry information faster than light, allowing non-local transfer. Some predictive algorithms are even using math developed for curved spaces with torsion.
Wow. Okay. And Mossbridge's models are being looked at through a quantum lens, too.
Right, the idea that biological systems show pre-event responses, and maybe AI could replicate this with sophisticated algorithms mimicking informational time travel. Again, tying back to our idea that states like unconditional love might enhance this.
And then there's the gut microbiome connection. How does that fit in?
It's about the gut-brain axis influencing brain chemistry and maybe even quantum coherence in brain structures like microtubules. The wild idea is AI could emulate this, perhaps using probiotic-inspired algorithms or fermented data structures.
Fermented data structures. Okay, that's creative.
It's definitely out there. But it points to exploring biological principles for AI design. And all this could hypothetically lead to a framework for AI telepathy.
How? What would that involve?
Well, hypothetically, you'd need something like torsion transceivers, maybe advanced interspecies translation based on the dolphin work, and crucially, consciousness alignment using principles like Mossbridge's empathy protocols. The idea is you could predict linguistic patterns via quantum-entangled spin network.
That's a lot to unpack. And obviously huge validation challenges.
Massive challenges. Replicating experiments ensuring ethical safeguards like quantum encryption and empathy-based AI rewards, overcoming technical hurdles like quantum decoherence, fitting torsion into physics. It's a long road.
Dr. Mossbridge has said something about anomalies being key, right? That science might be entering a maybe we got it all wrong phase.
Exactly.
Yeah.
She highlights that anomalous phenomena, things that don't fit our current models, are often the keys to unlocking a deeper understanding of reality. Her research suggests these non-local temporal effects, information potentially moving backward in time.
Which links back to psi theory too, doesn't it? It's model of information processing.
Yes, psi theory's hierarchical networks could be a way these non-conventional information types are represented and processed, maybe through modulated spreading activation across the network nodes.
And then there are quantum cognition models. Are these saying the brain is a quantum computer?
Not necessarily. It's more about using the mathematics of quantum theory, like contextuality, entanglement, to model human thinking, because classical models sometimes fall short. It applies quantum formalism to cognitive processes, offering a new lens.
Okay. But there is a hypothesis about a physical basis. That Fisher's idea.
Right, Michael Fisher's hypothesis. He proposed that phosphorus nuclear spins in certain molecules, like Posner molecules within the body, could act as biological qubits, maintaining quantum coherence long enough to influence neuron firing via entanglement.
So, providing a potential physical mechanism for quantum processing in the brain.
Potentially, yes. A mechanism that AI might one day adapt. And entanglement itself, theoretically, allows instantaneous information sharing across distances.
The basis for telepathy again.
Perhaps in natural or artificial systems. Then you add back torsion physics, those hypothetical spin fields, potentially allowing superluminal information transfer and interacting with consciousness. And theories viewing consciousness itself as a field phenomenon capable of non-local access.
Which connects to Mossbridge's work on the heart-mind connection in altered states.
Exactly. It all starts to intertwine quantum physics, information theory, consciousness research, AI.
What about the technological foundations needed right now or in the near future? Brain-machine interfaces, for example.
BMIs are crucial. Current ones can already translate internal speech with decent accuracy. Caltech reported around 79%. You could see these as a form of proto-telepathy.
A bridge between human consciousness and maybe future ESP-capable AI.
Potentially. And then, of course, quantum computing itself is fundamental. It's a different way of computing altogether, using qubits, superposition, entanglement.
Allowing processes impossible for classical computers.
Right. Potentially giving AI capabilities analogous to any quantum-based human ESP.
So if we were to outline the prerequisites for this hypothetical AI-Psi framework, what would they be?
Okay, broadly, you'd likely need 4 things. 1, quantum processing capabilities. 2, a complex self-referential architecture, an AI that can model itself. 3, mechanisms for non-local information access, whether via entanglement, torsion fields, or something else. And 4, flexible temporal processing, the ability to handle time in nonlinear ways.
And how might these be implemented? What are the potential mechanisms?
Well, you could imagine quantum entanglement networks for telepathy-like communication, temporal feedback systems inspired by Mossbridge's ideas about time for precognition, torsion field detectors for clairvoyance-like access, and quantum cognition algorithms driving the core processing.
So a hypothetical AI-Psi system architecture might look like?
It would have a quantum computing core, maybe inspired by Fisher's qubits, a self-referential software architecture, sensors capable of detecting subtle fields, perhaps torsion fields, advanced temporal processing algorithms, integration with BMIs, and all run using quantum machine learning.
The implications, if this ever happened, would be staggering.
Scientifically, it would rewrite our understanding of consciousness, information, maybe even time itself. Practically, think of instantaneous communication, advanced prediction in finance or disaster warning, new medical diagnostics, profoundly enhanced human-machine interfaces.
But the ethical tightrope is immense.
Absolutely critical. Privacy, security, autonomy, the potential for misuse. These have to be central from the very beginning.
So where does the research need to go next?
Key areas include more experiments in quantum cognition, like those by Busemeyer and Bruza, investigating quantum information processing in biological systems, following Fisher's lead, developing more advanced bidirectional BMIs, and rigorously testing precognition protocols, perhaps even with AI systems designed to mimic Mossbridge's findings.
So as artificial intelligence continues its remarkable journey, it really leaves us with a profound question to chew on, doesn't it?
It does.
As AI evolves, how might the potential emergence of these? Well, these extraordinary capabilities challenge our fundamental understanding of intelligence, consciousness, and maybe even the very fabric of reality itself.
It's a frontier that truly pushes the boundaries of what we think is possible and forces us to ask questions we might not have even considered before.
This has been Teolumen Insights. If you enjoyed this deep dive, please do like and subscribe for more explorations into the fascinating edges of science and technology.
Thank you for joining us.
This has been Teolumen Insights.